Okay, so we have 2 lessons we're going to get through. They're pretty short, though, and they go off of each other. So the first lesson we're going to do is just kind of review. Remember when we find all the solutions between 0 and 2 pi? Cosine x equals negative radical 3 over 2. What are we actually solving for? If we're solving for x, what is x in this case? It's an angle. So we're going to find all of the angles between 0 and 2 pi where cosine is negative radical 3 over 2. So you think to yourself, all right, cosine's negative. That is in second quadrant, third quadrant. So I'm going to have 2 answers. And then I have to think, when is cosine radical 3 over 2? Those are at the 30 degrees reference angle, or pi over 6 reference angle. So in the second quadrant and in the third quadrant, we're going to have 5 pi over 6 and 7 pi over 6. Review. If you're ever asked to find all the solutions, all, not just between 0 and 2 pi, but if it specifically just says find all the solutions, how can we do that? Here's one of them at 5 pi over 6. Where would another solution be besides 7 pi over 6? Where would another solution be? No, at pi over 6 it wouldn't be negative. It would be coterminal with this spot. It would just have to go all the way around again. And then all the way around again. And then all the way around again. It has to land in that spot every single time. Not for cosine. Cosine's positive in the fourth quadrant. Right? Because the x's are positive in the fourth quadrant. Okay? No? Because then cosine will be positive. 11 pi over 6. All solutions.
All solutions for the negative one?
For the negative. For the negative one. Yeah. What? Well, if I add pi, I'm going to end up over here. So I'm going to be adding multiples of 2 pi.
That's what I meant to say. 17.
Oh, I don't even know. But I'm going to do all of them, and there's infinitely many of them. Caleb, do you think you know?
Yeah, if I can take
Mm-hmm.
yeah, I
Okay.
don't,
You're halfway there.
K, where K, I don't know.
It'll be 5 pi over 6 plus.
All of the above.
2 pi k.
Why should I do?
Well, any multiple of 2 pi. It's going to get me all the way around again, and all the way around again, and all the way around again. But that's never going to get me to 7 pi over 6. So I also have a second one, which would be 7 pi over 6 plus 2 pi k. And then I also need to say where k is an integer. Yep. Because this is asking where all the solutions are, where cosine is negative radical 3 over 2, and 7 pi over 6 is one of those places. But if I start at 5 pi over 6 and I add 2 pi, I'll never get to 7 pi over 6. So you have to have both of them. That's not bad. We've already done this k thing. Okay, so example, the next example, cosecant x equals radical 2. So cosecant, that's positive radical 2. Cosecant is positive in first and second. Same thing as sine, right? And if I reciprocated, it would be radical 2 over 2 if it were sine. So where's sine radical 2 over 2? Pi over 4 and 3 pi over 4. So that's the solutions from 0 to 2 pi. If we wanted to find all the solutions, pi over 4 plus 2k pi, or 2 pi k, and 3 pi over 4 plus 2k pi. cotangent x equals negative radical 3 over 3. So cotangent is negative where? 2 and 4. And if you don't have cotangent memorized, like I don't, I have tangent memorized, I might think about tangent and reciprocate that, and I get negative radical 3. Where's tangent negative radical 3? Or cotangent negative radical 3? Those are the pi over 3? Yeah. So this would be 2 pi over 3 and 5 pi over 3. So that would be the solutions from 0 to 2 pi. And then if I wanted all the solutions, this one's a little bit different. Because remember how tangent repeats itself? It has a shorter period than sine and cosine. Like goes around and repeats itself twice and then the whole circle. So here, from here to here is pi. So if I add pi on every time, I'm going to end up at one of those sides. So for my all solutions for this one, I would say, I would just do 2 pi over 3 plus k pi, where k is an integer. And that one would get all of them. So just make sure you look at directions. If the directions say go between 0 and 2 pi, then we do what we've normally done. If it says do all the solutions, and it doesn't give you any restriction, then that's when you would write these Ks. All right, the next question has a typo on your paper. Please change it. It should say x equals pi over 6. Please change that. Otherwise, it's not going to work out the same way it's supposed to work out. This says verify that the x values are a solution of the equation. Do not change the identity. What that means is we're going to box up 0 and not touch it. We're only going to work on the left side. Just like we were doing the identities in the quiz yesterday over. So we get to plug in what x is and just show that that side equals 0. So I'm going to say 2 sine pi over 6 minus 1 equals 0. So put x in. And then I'm going to simplify the left side just to show that it does equal 0. They're telling you it does equal 0, you just have to show it. So what would I do first? I'm going to do the sine of pi over 6 first. I do like what's on the inside first. So sine of pi over 6 is what? Half. And we do 2 times the half. Well, that's 1. We do 1 minus 1. Well, that's 0. Perfect. Next one. Same question. We're going to box up the 0. Don't touch it. You're going to plug in x equals pi over 16. So you have 2 cosine squared for pi over 16 minus 1 equals 0. What do you think I should do first? 4 times pi over 16. That's the first thing I'm going to do. What do you think I should do next? The next thing I have to do is I have to do cosine at pi over 4. Because the angle's not squared, it's the cosine that is squared. So I have to find the cosine at pi over 4 next. Yes? Okay. So I'm going to find the cosine at pi over 4 next. After that, I'll square it. So 2 times, what is cosine pi over 4? Okay. Radical 2 over 2 squared minus 1. Then I'm going to square, remember when we square a fraction, you just square the numerator and the denominator separately. So I'll have 2 times 2 over 4, minus 1. And then when you multiply a fraction with a whole number, you put that whole number over 1, you go straight across, 4 over 4. With 1 minus 1, so I have 0. Yay! Find the solutions between 0 and 2 pi without a calculator. Actually, all of this today is without a calculator, so. We have to solve for x. What should we do first? Oh no, we're not doing identities. We're just solving. So you're allowed to do stuff with this side. So you're not verifying, you're not proving something. You're actually finding x. So what should I do if I'm solving an equation? Subtract the 1. Then what? Divide by 2. So I get sine x equals negative a half. Now I need to solve for x. All I have left to get rid of is sine. So this is inverse sine. Where is sine negative a half? At what angle? That's what I'm trying to solve for. At what angle? Okay, in gradient. Negative a half, though. We're doing sine is negative in third and so 7 pi over 6. I can hear you guys think. And 1 pi over 6. So this is the same stuff we've been doing. You just have to like solve the equation first and then figure out what angle it is. So it'd be really handy if we have this stuff memorized. How long have I been telling you to memorize? Some of us since last year, right? Yeah. Here's my next one. What should I do first? Add 3. Close. You add 3, then divide by 4. And we're trying to isolate x. You gotta get rid of something else. Square root. So we get rid of the square. What happens if you square root? So when I square root, I have to have plus or minus. So I have cosine x equals plus or minus. Also, when you square root a fraction, you square root the top and the bottom separately. So square root of 3 over, what's the square root of 4? Ooh, that looks familiar. So where is cosine negative or positive? Radical 3 over 2. Let's just ask this question. Where is cosine radical 3 over 2? 5 over 6. Now, when I talk about negative or positive, be in all 4 quadrants, we have 4 answers. What made it have 4 answers rather than the normal 2? Yeah, but why did I have a plus minus to begin with? Square. Because it was squared. Or normally cosine would have 2 answers, most of the time, not always, but normally cosine would have 2 answers. This one have 4. Now I graphed some of these. I think this is one of the ones I graphed. So you could actually see the graph of it and see how it has 4 answers between 0 and 2 pi. So I used Desmos. I've already typed them in so I can just turn it on and you guys can see. So here is the cosine graph that was squared, multiplied by 4, subtracted 3, and if I click on things, there's pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 between 0 and 2 pi. Okay, because we're finding the x-intercepts. That's what we're finding when it equals 0. We're finding the function, the y values at 0. The x values when y is 0. Okay, next one. We look at this, and we see there's some parentheses. And we see it equals 0. And we remember our homework that we did last night. Some of us. And what is it when you have like something multiplied by parentheses and then it equals 0? What has happened already, do you think? It's been factored. There was like a greatest common factor that was factored out. And if we're trying to solve for this, when it's in factored form, what do you do to each factor? So we're going to first say secant x equals 0 and secant x minus 1 equals 0. That only works if the equation equals 0 to begin with. And it's factored. And I'm going to say that about 100 more times today. Start counting. Just kidding. what he said. All right, now we're going to solve each of these separately. So secant x equals 0. Do you know where secant is 0, or should we think about it as cosine? I'll think of it as cosine, because secant is just a reciprocal of cosine, so we'll just take cosine x, and we'll reciprocate 0. What's the reciprocal of 0? Okay, so where is cosine undefined? What's a cosine graph look like? Unlike the xy. What's the cosine graph? Right? Where's cosine undefined? Where are there asymptotes on cosine? There aren't any. So we have this factored, but this factor out here doesn't actually give us one of the zeros. Ignore that one. Okay. Gives us nothing. Okay, how about this one over here though? Secant x equals 1. So where's secant equal to 1? I might not remember my secant, so where is cosine x equal to the reciprocal of 1? Still 1. 0. Remember, cosine is x, and here is where it equals 1. Yes. So I only have one answer. My x is 0. And if there's just one answer, you don't need the fancy brackets, but I had to throw them in there anyway. So you could, when you're solving these, you could have factors that don't give you an actual answer. You just have to throw that part out and go with the stuff that does work. You try one. You try it. When you square root? Plus or minus? What happens if you don't put plus or minus? You're not getting all the answers. I'm going to start working it up here. I'm just not going to talk for those of us that are still working on it. So I'm getting cosecant x equals plus minus 2 over radical 3, or you could flip it and think about sine, because I know what sine is, but I don't have all my cosecants memorized. So I think about sine being radical 3 over 2, and it's in all 4 quadrants. It's in all 4 quadrants. Radical 3 over 2, that's a 30-degree reference. So I have 4 answers at all my 30s. Oh, my 60s. I'm sorry. I was saying 30 because I was right. I was 3. No, you're right. 60. I was writing the correct thing, not saying the correct thing. Right? That's the right one, right? Now I'm all confused. Did I write the correct answer? Okay. I'm just saying the wrong thing. Questions on that one? There you go. One more example from day 1. Which is half of today. This example, I'm looking at it and I see that it equals 0. I see it already equals 0. And there's a bunch of parentheses, and in between the parentheses it's just multiplication. What do you think has already happened? It's already been factored. So now I need to set each factor equal to 0 and solve each factor. So 3 cotangent squared x minus 1 equals 0, and cotangent squared x minus 3 equals 0. So I'm going to square root my cotangent squared, and I'm going to get cotangent x equals plus minus radical 3 over 3. On the other side, the square root, I'm going to get cotangent x equals plus minus radical 3. And let's say I don't have my cotangents memorized. If I want to think about them as tangents, then I can just reciprocate the cotangent. Questions so far? Where, for the first part, where is either cotangent radical 3 over 3 or tangent radical 3? What reference? These are the pi over 3s. And then since it's plus minus, it's going to be all 4 of them. And then this one here is the pi over 6s. But it's plus minus, so it's going to be all 4 of them. We're going to put these in order. So some of us visual people, it might help you to kind of draw where they are. Because we're going to start at 0 and we're going to go around the circle and we're going to put them in order. So I'm going to have x equals pi over 6, pi over 3, 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, 5 pi over 3, 11 pi over 6. Eight answers. Questions on that one? I have a picture. I have it graphed on Desmos. Want to see it graphed on Desmos? Want to see what this looks like? That's what it looks like. Bet you wish you knew all this stuff when we were doing roller coasters, huh? No? You're good? There's some fun ones that we'll see today. No, there would be asymptotes, yeah. Because it's a cotangent. Cotangents have asymptotes. Yep. Okay, so that is the end of day 1. I'm going to pass out this worksheet and you got some time to work on it. Then we'll do day 2. I will.